Alright, now that we have taken an introductory look at the sprite batch object, and we've seen how we can use sprite batch to draw sprites to the screen, let's go ahead and shift our focus over to drawing text to the screen. Now text, of course, is still going to be a sprite. As a matter of fact, in the last video you saw that we were able to go in and sample from a bitmap and pull out our own characters, if you will, our own numbers, and display them with a sprite batch to the screen. Of course, doing that with the whole alphabet and a whole series of numbers as well would become a lot more involved. Fortunately, as of XNA 1.0 refresh, we have a built-in ability to easily display text. Now, we'll still be using a sprite batch to do it. We'll be using the drawString method of the sprite batch. Now, in order to do this, we need to understand a few elements that are involved. We're going to need to have a little understanding of the sprite font asset, which will need to be added. And the sprite font asset is going to tell the content pipeline what sprite we're interested in using. We're going to need to be familiar with a sprite font object. Once we're familiar with the sprite font object, we're in good shape because we can use the content manager to load the font into a sprite font object, and then we can use sprite batch to draw it out. Woo, sounds confusing, right? Nah, it's actually really simple. Before we get started, let's go ahead and give a quick overview of the things we're going to be looking at. Now, let me throw this out there real quick. Keep in mind, we're going to be using true type fonts. Most true type fonts have some sort of licensing, which means please make sure you are familiar with the licensing of a particular font if you're planning on distributing it, because you most likely are not allowed to. So that's very important. So just keep that in mind. Don't just go out to the internet, find some font, and distribute it. Okay, I just wanted to point that out real quick. So first of all, what we're going to do is provide an overview. The overview is simply going to show you how all of these pieces that I just rambled off just a second ago interact with one another in order to give you the capabilities of drawing text to the screen. Once we've taken a look at a drawn overview, we're then going to do it. We're just going to set it up. So set up and draw some text. We'll keep it nice and simple. We'll do something like hello world. We're not going to worry about anything super critical to start with, but then we're going to start getting a little bit more interesting. We're going to take a look at the XML file that the content pipeline uses in order to construct the actual font you'll be using in your game at runtime. So we're going to see how we would go about adjusting properties inside the XML file, which will, of course, affect the final font asset. So adjust XML file. And this XML file is going to make a lot of sense in just a few minutes. After that, the next thing we're going to do is we're going to take a look at how we can use measure string to figure out how wide a particular piece of text is. Then, once we can figure out how wide that text is, we can use it for doing things like centering. So we'll center the text. Okay, so at this point we're starting to get a little fancy. Then we're going to move into the world of things that you are a bit familiar with now. We're going to show you how we can do rotation, how we can control the origin. As we've already seen, that's very important with sprites, or it can be anyways. So of course, after showing the origin, we're going to show you how we can then go back to rotation and control rotation with an origin set. From there, we're going to take a look at uniform and non-uniform scaling. After we've looked at uniform and non-uniform scaling, we're then going to talk about the differences, just bear with me here, between size and scaling. See, we're going to have a size property that we can adjust in the XML file. No different than if you were working inside of Photoshop or Word or some other application that dealt with text and fonts, and you were able to go in there and say, you know, I want this font to be size 24. Now it's going to be a big font, or size 14. Ah, that looks a little more normal. All right, well, we have size in the XML file. But when we're scaling text, of course, now we're making the text look bigger on the screen. But there's a very distinct difference between using size or using scaling, and we're going to show you exactly what's going on there. So after we look at that, the next thing we're going to do is we're going to, of course, quickly demonstrate sprite effects once again. Just in case you need to flip some text around. After sprite effects, let me throw an S on the end of that. We're then going to talk about the final property in the XML file, which is going to be our character regions. So throughout this video, we're going to actually talk about pretty much every single thing that's involved with using drawstring for drawing text. By the end of it, Logan, since we are going to show all three of the overloaded methods for drawstring, they're set.
Yeah, we will have covered everything that can be set up from the XML file, as well as everything that the drawstring method can do.
Yeah, so it's going to be a really cool video. Let's go ahead and start out with the overview. So where does it all begin? Well, like with a texture, how does the whole texture thing work? Well, with a texture, you simply create your texture. So now you have a PNG or whatever it may be sitting out there. You then use the content pipeline to import that in, okay? And in importing it, it's just really getting everything all set up so that at build time, the content pipeline knows to take that asset and import it, process it, and compile it to an XNB file. Pretty much the same thing is going to happen when dealing with a sprite, or excuse me, a sprite font, or let's just say font. First thing we're going to need to do is we're going to need to add a sprite font asset. So we'll simply add a sprite font asset to the file. Now, at this point, this doesn't mean that font has to exist on the computer or anything, because what really happens is an XML file gets generated. So the result of this is this XML file. Dun, dun, dun. And this XML file really just contains a bit of information for the content pipeline to use in order to generate the actual font that's going to be in the game, or that you're going to have access to through the content manager in the game. So this XML file allows you to go in there and set things like the font name, so that we can say we're going to use Arial or we're going to use Tahoma or whatever it may be. Let me fix my F there. That's better. Things like size, things like spacing. While all of these are probably very obvious, we will demonstrate them. Style, such as we're going to destroy. How are we going to draw the text as regular text, bold, italicized, bold, and italicized? So we'll walk through all of that. Now, the next thing that happens is build time. Dun, 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 dun. Magical cloud. Content pipeline. And what are we doing? We're building. The content pipeline will take this XML file into process and out of the pipeline and producing an XNB file. This, ladies and gentlemen, is now our font as far as the XNA world goes. All right. So now how do we use this font? It's really quite simple. In our game, so here's what I want to do. Let's just put kind of a dividing line right there. Inside our game, we're going to create a sprite font object. And the sprite font object is going to serve as the object that will encapsulate the font itself. But we need to get that data loaded into sprite font object. It's really no different than if we had a texture that brought in, and of course what happens with the texture? It also ended up being stored in an XNB, and then we needed a texture 2D in order to hold that data. Ta-da! Same thing's going on here, except we're going to use a sprite font object to hold the data. But we need to get that data loaded, and we all know how we do that. We will use the Content Manager. Gotta love the Content Manager. His job will be to load the font in. Dun. Alright, so let's go ahead and box this in real quick. Okay, so at this point, we'll be sitting there ready to draw out some text because we've got a font that we can use. How do we draw it out? Well, of course, we're going to need to create a sprite batch object. So we'll just say create. I'll just say create and setup, but I'll just write create sprite batch. Object. And then down in draw, what do? We've got a sprite batch begin, a sprite batch end, and in between, we're going to call upon the sprite batches dot what? Drawstring. That's right. So we'll call upon spritebatch.drawstring, and drawstring is going to have 3 different overloads for us. Let's see. This is video after all. You can always fast forward if I'm, throwing out too much stuff. Overload number 1. Just give you guys a little bit of extra stuff. What do you think about me doing this, Logan? Sound good to you?
Sure. Just give a preview of how the method's going to work.
Yeah, exactly. So first one's going to be what font? So I'll just put a question mark. So we're just going to point to a sprite font object. So we'll do what font we're going to use. And the next thing we're going to do is going to be what text. So this is where we can actually just, give it a string value. And we'll just put in something simple to begin with, like hello world. Next is going to be location. Where do you want it shown at? And then finally, color. What color do you want it to be? Very simple overload for drawstring. Now, there's 3 of them. The second and third one are almost identical. Of course, we're going to start out again with what font. So again, what sprite font object are we going to use? Then, of course, it's going to be text. So what text do we want to display out? Position or location. I'll just put location again. What color? So far, it looks very familiar. Wow, rotation. So what rotation will this text have? What will the origin be? So we can pass in an origin. Then we've got scale. Then, of course, any effects. Do we want to flip it horizontally? Do we want to flip the text vertically? And then finally, layer depth, which I'll write it down, but it's something we're getting into later. Layer. Okay, so focusing on everything except for the very last one, which we'll get to later. Overload number 3 looks exactly the same all the way down to scale. And after scale, the rest of it is the same. But the scales are going to be a bit differently. One is going to be, this guy here is going to be a float. So we just simply specify 1. That's a scale of 1. 2, double the size. But it is a uniform scale. The scale over here, though, is going to be a vector 2. Now we can say scale the width, but not the height. Or scale the height and not the width. So we get a lot of control. So these are our 3 different overloads that we're going to be using. Again, this whole thing is just so simple, and by the end of this video, you really are going to be an expert with utilizing sprite font objects and the drawstring method to draw out some text. So this is the overview that I wanted to give you. Once again, a very quick recap before Logan starts doing it, is the whole thing begins, let me grab out a pointer, the whole thing begins with us adding a sprite font asset into our project. Once we've added that in, that means we now have an XML file that we can adjust the font name, the size, the spacing, the style, and the character regions as well, which we'll talk about at the end of this video. I don't even want to mention it here because it could really confuse somebody. Let's keep things simple. So you adjust all of these things, and then when you build your game, the content pipeline will take and import, process, and compile this information and the actual font into an XNB font that can then be used inside your game. Once that's been added in, it's our job as a programmer to go in there and create the sprite font object, use the content manager to load our font into the sprite font object. Then, of course, we'll create a sprite batch object, and we'll use the drawstring method in the draw method of the game to simply draw out the font, or draw out the text utilizing the font that we've brought into the sprite font object, using one of 1, 2, 3 overloads. Okay, so there is the overview. So at this point, Logan, let's now move on to the next part, which is setup and draw some text. And boy, I wrote setup with 2 T's. That's awesome. All right, so go ahead and grab Visual Studio Express.
All right.
Let's go and create a new text demo.
All right. So we're going to create a Windows game, and we'll call the project Text Demo. All right. Now with our new project, the first thing that we want to do is to add in the sprite font asset itself. I'm going to add it into a textures folder, since the idea is that the data is similar, and until we have so many assets that we need further categorization, I'm just going to leave everything in textures. But with this textures folder now, I want to add the sprite font asset itself. So I'll right-click on textures, we'll go to add, and then we'll go to new item. Inside of the templates, we have a sprite font. And with that sprite font, we can see it has a default name of spritefont1.spritefont. Now, one interesting thing to note about sprite fonts is that the name of the asset will also be the default setting for the font property itself.
For the font name, that's right.
So that means if one were to desire the Tahoma font, one could name the sprite font asset Tahoma, and then when it's created, that will be the default name. So I'll add it in as Tahoma.spritefont. And after the asset is added, we can see that it also gets loaded into the editor. So now we're looking at that XML file that is going to describe the font to the content pipeline.
So we haven't actually created an XNA font. All we've done is brought in an XML file that will describe the font.
Exactly. And you can see that the first property here, font name, is indeed set to Tahoma, just what we named the asset. Now, it should be noted that this name doesn't have to match the asset name. I could set it to something else like Arial, and it would still build. As a matter of fact, let me go ahead and do that. A-R-I-A-L, and build. And there were no problems in changing it. Just to note that if it was more convenient to name the asset something like main menu sprite font.
To show them real quick, put a bunch of Z's at the end of that Arial. And build again. And you'll notice we now have a compiler error. So when Logan just changed that name, it was critical that the font name does indeed exist. If it didn't exist, well, you get the error that you got now. The compiler is not going to let you go through with it.
Right. The font must exist on the system that you're building on.
So switching it from Tahoma over to Arial worked just fine because the font was found. Okay, cool.
I'm going to leave it to Tahoma for now, and we'll revisit this file a little bit later when we take a look at the properties.
Okay.
But now the next thing we want to do is draw it.
Draw some text. All right.
So I'm going to close out the sprite font asset for the time being so that we can focus on the game. Now, things that we'll need to set up in order to draw the font. Well, we've talked about using a sprite batch to use to draw it. We're going to need the drawstring method, so we're going to need a sprite font. We're also going to need a sprite font itself, a sprite font field. So let me create both of those as fields of the game class. First will be the sprite batch, which I'm simply going to call sprite batch, and a sprite font field. So this will be of type sprite font, and I'm simply going to call this field font. Alright, next thing I'll do is make sure that we create the sprite batch inside of initialize. So I'll drop down to initialize and say that our sprite batch is equal to a new sprite batch, and of course we need to give it the graphics device. So graphics.graphics device. Alright, now we can go back to focusing on the font itself. I'm going to jump down now to load graphics content, where we can use the content manager to load the font. And this should feel very similar to loading a texture. The way I'll do this is to say that our font is going to be equal to content.load, and then the type that I'm going to give to load is going to be sprite font, because that's the type that we're dealing with our reference. So we'll tell it that we're loading a sprite font, and then I'll give it the asset name itself. So I'll begin with the @ symbol so that we have a literal string. Of course, we're storing it in the textures folder, and the asset is called Tahoma. Just like any other asset, we don't include the file name. The content manager simply assumes that there's going to be an XNB file to go along with this name. And with that, when run, should load in our Tahoma font into this font reference, or sprite font reference.
Okay.
So with everything loaded at this point...
All we need to do is initialize some drawing action, which is basically a sprite batch begin, use the draw string, and sprite batch end.
Alright, so let's jump down to the draw method and plug that in. Let me start with the sprite batch begin, and I'm going to immediately throw in the sprite batch end just so that I don't get carried away in a minute and leave it out. Now I'm going to jump between the sprite batch begin and end, and now we can make our call to drawString. So sprite batch.drawString, I'm going to use the first overload, the one with the fewest parameters, and let's take a look at what it needs. Well, that's the same as what you've already drawn out on the whiteboard. We need a font, some text to draw, position, and a color. The font is going to be our reference to that sprite font, called font. The text, for the time being, I'm simply going to put in the literal hello world.
Oh, yeah.
And for the position, I'm going to leave it 0. I'm just going to plug in vector2.0. And the color I'm going to use will be yellow. So color.yellow. This will contrast nicely with the blue background.
Okay.
So with everything put in place, I'm going to build to make sure I haven't introduced any errors. The build has succeeded, so now we can go ahead and run. And there we go. We have the text hello world drawn to the screen in the Tahoma font using the color yellow.
Excellent. So at that point, let's go ahead and close this right here. That means we have now shown you how we can set it all up with my 2 T's and draw some text out. Now let's go ahead and turn our attention over to this XML file and take a look at changing things like the font name, the size, the spacing, the style, etc. So let's go ahead and jump back over here into Visual Studio.
All right. And I'm going to load up the Tahoma.sprite font asset again. So let's take a look at the properties in here. We've actually already taken a look at font name. So now we can move on to things like size. Now size is just going to control the point size of the font that was used when building the texture. That means I could use a point size of 24 to generate the texture, which will result in larger text, as one would probably expect. We can, of course, set it lower. I'm actually going to leave it 24 just because the larger text will make it easier to see on this recording.
Okay.
The next property we have is spacing, and this simply controls how much spacing there is between characters in the final rendered text. We could set this to 0, leave no spacing, and then when we build and run, we see that the characters are actually bunched up on each other more.
Right.
And
actually this is touching.
Yeah, and this is useful simply because a lot of fonts will have different default spacing, and you might want to go and adjust that to make it look correct when rendered in your game.
And of course, that default spacing could have too much space in there, so you can also set this number to negative.
So we could plug in something like -5. And since the Tahoma font wasn't spaced out that much to begin with, this is actually causing the characters to overlap. So, I mean, one can indeed do that. One can cause the characters to overlap.
But it is cool that you have that control.
Right, it is. It's always nice to have good range on control for things like this. Though for the spacing setting, I'm going to leave it at 2, since that's working well. The default works fine for the Tahoma font.
Okay.
The next property we have is style. Style lets you control things like bold, italic, or a combination of the two. So we could plug some of these in to demonstrate them. We could show bold, which is going to cause the text to display in bold, as one would expect. We also have italic, and we get that result. We get italic text.
And again, everything needs to be typed properly here. If you misspell it, you will get a compiler error.
If we try to build with italic misspelled, that means that that is not a valid setting for this property. One last thing that we could show is a combination of bold and italic. So bold, comma, italic will produce the results of bold and italic combined.
Very nice.
So that's just quickly showing what all of the settings actually look like. For now, I'm just going to leave this bold.
Okay.
That should once again have a nice strong text, so it should show up really well on the recording. The last property that we have is the character region, and we'll get into that more towards the end of the video. We'll show exactly why you need to have character region adjustments.
Okay. All right, so now we have taken a look at adjusting the XML file. Let's see how we can go about measuring the string and centering up this text on our screen.
All right. Because, of course, right now we're just drawing at 0. So let's see what would be necessary in order to take this text and draw it centered on the screen. We know that the first part of that's going to be knowing the screen size itself. So I'm actually going to begin this by setting up some constants just so I have easy access to the size of the screen. So I'll make some constant integers called screen width, which we'll set to 800 in order to match the default XNA game setting of 800 by 600. So I'll set up a screen width of 800 and a screen height of 600.
And again, this is for demonstration purposes only.
Right. The idea is just that at the time of drawing the text, just to make sure that we know what the screen width and height is. In this case, I'm just going to hold those in constant. So now that we know the screen size, we can easily find the center of the screen. And I'm going to store that in a vector 2 called position. So we could say that a position for the center of the screen is equal to a new vector 2 where we could feed in screen width divided by 2 and screen height divided by 2. So this will give a point in the middle of the screen. And we could show that in use before we do the final offset. I could go ahead and actually use this position, and we can see what that is currently looking like. So while this is more centered, we can see that it's not the exact center for the text.
We can see that the origin is at 0, 0 on the text itself, so it's the upper left-hand corner. So that's the center of the entire screen. So we need an offset to account for, well, the width of the string itself.
Right. And that brings us to measure string. We need to see what the graphical width of the drawn text hello world is. And for that, we will need the measure text property, the measure text method. And since we're going to be reusing this text a few times, I'm actually going to replace it with a variable. I'm going to declare a string variable called text, and we'll set that to hello world, just so that we can reuse that variable in multiple places. First place is, of course, going to be the call to draw string. Now we can focus on the measure text method. Now, I can actually write this out. The measure text is found under the sprite font itself. Our reference to sprite font is, of course, called font. So if we go into font, we can see we have the method measure string.
That's okay. You were going to pull it up in a second. You kept saying measure text.
Oh, whoops! I didn't even realize that.
That's okay. I've already showed them that it was measure string, so everybody was with you.
Place text string, but yes, the method is measure string.
We were all with you.
Measure string takes in the string that you would actually like to measure. And I'm going to plug in the text variable. This is why it was important to have the variable, so we could have the same text measured and then later drawn. Now let's take a closer look at measure string, and you can see that the type it returns is vector 2. So it's actually going to measure the width and the height at the same time and return a vector 2.
That's right.
That's actually very convenient in our case, because that way, instead of having to dive into the x and y components of position, we can simply take all of position and then minus the result of the measure string to center up our actual text. So that means we could say that position minus equals font.measureString. So I think that should do it. Let me
now. Do you want go ahead and run it? And here's the deal: we're taking the entire string. We need to divide it by 2,
I see
so
where
that
you're going with
it only
that.
goes halfway over.
Well, and you can already see that we were expecting the correct result, but we didn't get it. And the text is now too far to the left and top. And that was
we took into account the entire width of the text.
Where when centering, we're taking that width divided by 2. And if you remember the past videos when we would get the center of a graphic, we were doing the same thing. We would get that graphic's width and then divide that by 2. So we actually need to offset by the measured dimensions divided by 2 to get the actual center.
And there we go.
And then we'll get the actual center.
Perfect.
So, but very good. We're drawing the text "Hello World" centered on the screen based on the size that our font properties ended up giving us.
So go ahead and show them a larger font now. Let's turn it up a bit.
Let's double the font size up to 48.
Okay.
And rebuild.
And there you go.
So larger text, still centered.
So it's working out well. Very nice. All right, go ahead and bring the font size back down. We'll get back to larger fonts in just a minute. All right, so at that point, or at this point now, we've got measure string out of the way. Rotation. So now we're going to start looking at utilizing overloads 2 and 3 of the drawString method.
All right.
So let's make this guy rotate.
And in order to rotate, just like you said, we're going to need to utilize overload 2 or 3. So if I go into the call to draw string and add another parameter, and you see immediately with the tooltip for the next overload, and the next parameter within that is rotation. I'm going to, let's see, I'm going to put in a variable. I know I need to declare this one, but we'll come back to that in a second, because first I want to finish off the signature for this overload. Because along with rotation, we also need to specify some more things. A vector2 for an origin. I don't have an actual specified origin yet, so I'm simply going to put in vector2.0. The next parameter is going to be a float scale. I'm going to give it 1f for a scale of 1. For the sprite effects, I'm going to give sprite effects.none, since I'm not interested in flipping the drawing at the moment. And the last parameter, layer depth, which we're not going to get into at all, and I'm simply going to put in as 0f. That has the call put together. Now I need to declare a variable for rotation. So I'll simply drop in below position. Rotation is going to be taken in as a float. So let's make a float rotation, and let's set that to some value that is going to increase over time. As a matter of fact, we could just set it to the total number of seconds the game has been running this far.
That'll work.
So we could give it game time dot total game time dot seconds. I'm going to multiply this value by 2 just because seconds moves fairly slowly.
Right, speed it up.
I'm also going to have to cast this over to I've got this actually typed in wrong. I was looking at the type. The type was an integer. That's because the one I'm looking for is total seconds, not just seconds. Total seconds, let me correct this, is a double, so I'm going to need to cast this to float before I store it. But now we should have the time in seconds stored in rotation, which is later plugged into the drawstring. So let's run and see what result this gives us.
Hey, rotating text. Of course, at the moment, the origin that Logan's using is that vector2.0, so 0, 0, which means, once again, upper left-hand corner of this sprite.
All right. But that does indeed take care of rotation.
So that means we get to, well, I guess I can just knock that off real quick. So now that we've got some text rotating, we need to set this origin so that with the origin we can then make the text spin around from its center.
All right. Let me begin by declaring a variable for this. The rotation is given in a vector2, so I'm going to make a vector2 variable called origin. And let me think about this for a second. In order to center this up, we would need to set the origin to half the width and half the height, much like we had done in previous projects where we would set an origin for a centered sprite.
Mm-hmm.
And in order to get half the width and height, we could use measure string.
Mm-hmm.
As a matter of fact, we could use this exact line. So I'm simply going to copy this entire thing, font.measureString for text divided by 2, and paste that in here so that the origin is actually equal to the result of that measure string.
Yep, very nice. And then, of course, let's go ahead and turn around and use origin now.
So let me scroll over to inside of the call. Just to make sure that we're plugging this into the right place, I can bring up the IntelliSense tooltip, so Control-K followed by P. So we can see that, yes, this vector20 is in fact the origin. So I'll put in origin here, and then we can run. And now we have the text rotating around its center. But you'll notice that we no longer need the positional offset. Since the text itself is drawn at its center, as rotating at its center, we can take out this positional offset that we had specified ourselves. So I can take away this line entirely. And we can allow the text position to simply be the center of the screen. As now origin is handling not only our rotation origin, but our position origin as well.
Very nice. All right, so now we've got origin working. What are we going to do next? All right, so now we get to look at both uniform and non-uniform scaling.
All right. Well, that is one of the properties of this overload. Again, I'll bring up the IntelliSense tooltip to make sure that we're looking at the right one. We can see we have the float scale, which I have currently specified as 1F. This is the scale version, and therefore the float version, and is therefore going to be the uniform version. So if I would just set this to 2, we should see the entire text get scaled up by a factor of 2.
Very nice.
Or, just for demonstrational purposes, all the way up to 4, so we have giant text. We can, of course, scale to a value less than 1, so I could plug in 0.5f, and we would get our text scaled down to half size. Okay.
Now, of course, Logan's doing a uniform scale. We also have the ability to not do a non-uniform scale where we're specifying that we just want to scale up the width or the height.
Alright, let me bring up the tooltip once again so that I can drop down to the third overload where we see that scale parameter change type to vector 2. So if we wanted to use this overload, I could replace this value with a new vector 2 and specify whatever scale we would like. For demonstration, we could make the text twice as wide and a normal height.
Okay.
So we'll do a vector of 2 by 1. And if we do that, we have text stretched out in width.
Very cool.
So one can easily specify non-uniform scaling if they wish.
Okay.
And
now, go ahead and set the height to like 3 just real quick, or
sure.
4, either one. All right, very cool.
So there we go, full demonstration of non-uniform scaling.
All right, now back over here, the next thing that we need to talk about is the difference between that size property and scaling, because there's a big difference. Logan, you want to show them?
Let's let me set the text size back to a uniform scale of 4. So
Okay.
I'll give it 4F, and then note what's happening with the text scaling. You can see on especially the letter W. Watching the sides, it looks rather pixelated on the sides.
Yeah, very blotchy.
This is because the source texture was generated for a point size of 24, but then we took that resulting texture and scaled it up. So we're actually causing there to be some filtering in place when it's drawing that. If we were to adjust the point size in the sprite font setting, the size property is going to adjust the point size of the font that is used to generate the texture, which essentially means the larger you set this number, the larger the source font texture is actually going to be. To demonstrate the visual difference, I could set this scale size back to 1, but then increase our point size by 4. So I could jump the font size up to 96 and build. But notice that the build is going to take longer when we do this. Since this is a rather large font size, this means it has to make a texture large enough to accommodate characters, where each character is of point size 96.
Exactly.
So that should also be kept in mind, as not only is that going to increase the build time, it's also going to make a much larger file in order to hold this texture data. But now with this built, I can demonstrate a font size of 96, and you can see that the font is much clearer. As a matter of fact, that's razor sharp on all of the edges, because we actually have the texture data scaled to that size instead of a final scale of a smaller texture.
Very cool. But once again, keep in mind, larger file.
So what I'm actually going to do is set this back to 24, and we'll leave it at that. I'm not sure why I ran again, but yes, this has indeed lowered the font size back down.
So that's the difference between, if we were to come back over here real quick, the difference between size and scaling. Sprite effects. All right, this one will be quick. Logan, let's just go ahead and show them how they can flip the text.
All right. Quick build just to show that this is where we're sitting right now. Smaller text at a sprite effect of none. We could change sprite effects to be maybe flip horizontally. And if we do that, we do indeed have the text flipped. It should be noted that the entire string that's drawn out gets flipped. It doesn't flip character by character.
That's right.
We could, of course, do flip vertically as well. And we could even combine them if we wished. We could use sprite effects, flip vertically, pipe symbol for or, sprite effects dot flip horizontally. And we could flip in both directions, which produces an interesting result because we're rotating. Let me actually take the rotation out for a second.
Okay.
I'm going to simply set rotation to 0. And we can see that, yes, we are flipping. It was confusing to show because we're completely mirroring it, but then we're rotating, which rotating is going to result in upside down at some point anyway.
Right.
But just to show that
so it worked out.
We could set the sprite effects however we want.
Okay.
I'm actually going to set this back to none, but that shows what results you would get.
All right. And so back over here on our objectives, the only thing that we've got left is character regions. And this is pretty important if you're going to start using some of the funky characters that are involved in the character map.
All right. Let's begin with a look at what's currently in the texture region setting. If we jump back over to the sprite font and scroll all the way down to the bottom where we're looking at our character regions, we can see that we have a character regions block, and inside of that we have a single character region which has a start and end property. These properties are given to show basically where in the character map we start and then specify a range of characters that this font is going to include.
Let's go ahead and pull up a character map real quick.
One thing real quick inside of the XML editor, we actually have tooltips for the given characters. So we can see that the character 32 is the character space and then also gives the hex value.
Okay.
So we can see at this current range is going from space up into the tilde character.
Okay.
Now, in order to get an idea of what we're talking about with the character map, I could actually bring up the Windows character map, and we can show how this is working. Now, some of these may not line up in the big picture exactly, but we can see that we're starting at 21, so let me hover over this again. Hexadecimal character 20, so the character map isn't showing the character preceding this one, but we can see that we're roughly starting off here at the exclamation point, and we want to find the end of the range we've got, so we're going from 20 all the way, or excuse me, from 32 all the way up to 126. Now you notice that a lot of these are given in hex instead of in binary. So once again, when I was saying that the tooltip would show the value in hex, we can see that the ending character is 7E. So we can use that to look up, alright, we're about 77, 8, A, B, C, D, E. There we go.
And tilde.
And that does indeed represent the tilde character. So we can see we have this range from here to here. And this is a good default range because it gives us things like letters, uppercase, lowercase, numbers, and a set of symbols. Basically, most things that could be typed on a keyboard.
Now the question is, why is this important? Well, simple. There's no reason for the content pipeline to actually construct a font that's going to be an X and B file that contains data for every single character there if you're not going to be using some of these characters down here. These characters aren't going to be used. Why would we want to create a font that held all of this inside that file?
Right. Each of these characters are taking up valuable texture space inside of our font. So we want to make sure that we're only building a texture that contains the characters we're going to use.
So what happens if you say, let's print out or display a particular character that's not in the font?
Well, let's take a look at doing that. Let us say, for example, that in our text in-game we wish to display this symbol, the yen sign.
Okay.
Now, the keystroke for that is given here, Alt 165. I'm not going to go through the casting of the number over to a character to store it. I'm just going to literally type it in. If I didn't want to type in the shortcut, of course, the character map gives facility for selecting and copying characters. I'm just going to type it in. So Alt 0165. Now we have a yen symbol placed into the string, but we have not yet modified our region. And if we look back at the region, our region stops here before we get to the yen symbol.
Okay.
So now if we try to run, everything builds, we start to run, but then when we get to this draw call, we throw an exception saying that this character, the yen character, is not available in the sprite font. We don't have it included in the character region. So I'm going to break out of this run, and let's take a look at what would be needed, or what we would need to do. One option would be to increase this range so that it includes this character. If I select over it, it's giving us the hex. In this case, we don't have to convert the hex because it's giving the keystroke in binary. So the character we're looking at here is 165. So I could, inside of this sprite font, set the the region end to 165, still with the yen symbol in the string, build and run, and now I have the yen symbol being displayed. Let me take out the rotation, just because that's going to kind of get in the way to see. So I'm just going to set the rotation to 0. There we go. And I'm actually going to take the bold out because it's making the yen symbol look a little funny. I know that doesn't really mean anything, but it's just kind of bugging me. And I probably spelled that wrong with a lowercase instead of uppercase letter. Alright, still not quite the respective result. I must have been using a different font earlier when I was testing this. So excuse the messing around with properties. But I mean, that is indeed the yen character, and we are indeed not getting an exception. So that's all well and good. But let's take a look at adding another character. What would happen if I wanted to add the TM symbol, trademark symbol? If I scroll down in the character map, we can see that the trademark symbol appears much lower. And while it has a keystroke and a very low binary value, actually that is 153, which one would assume would be in this range. But in this case, the TM symbol is being handled in a special way where we can't directly draw it. If I were to copy it in or just type in the character code to it and attempt to run, we're once again going to get an exception. And if we look at the character that it's showing it in hex. In this case, it is only using the Unicode address in order to access that character. Which means, back on the character map, if we match that up, there was that hex value, the Unicode character that we were looking for. Now, if I convert that to binary, as a matter of fact, I'm going to bring up the calculator just because I'm feeling lazy for the hex conversion. I'm going to switch the calculator over to scientific so that I can enter the hex value. What do we have here? 2122. and then switch back to decimal, and we can see that that would be the decimal 8,482.
Okay.
Now, we do not want to increase our range from 32 to 8,482. That would, while providing your build time actually finished, create an obscenely large texture. So what we're going to take a look at now is how we can add multiple character region blocks. To do that, I'm simply going to take the existing character region block, that is of course only the center one, not including the character regions block outside of it. So let's copy this character region block and simply paste it in below the first one. So now we have two character region blocks. Currently they both have the same starts and ends, but what I want to do is to include that trademark symbol. Once again, we had calculated that as being 8482 in decimal, so I'm going to punch that in here, 8482, and I'm going to make this entire range cover only a single character, so the start and end are going to be the same value. Now if you remember, we still have the trademark symbol here, so with this change, let's see if we can run and avoid any exception. And we can. There we have the character being properly drawn in game.
Very nice.
So we have extended our character region to cover the simple one, or excuse me, the defaults, then a little bit more for the money symbols, and then we added on one more character that was otherwise far out of range. Now with this in mind, with the ability to have multiple character region blocks, we could actually optimize our first block. If you'll notice, we have to go all the way up to 165, even though we're only adding in a few. Let's say I only wanted to add in a few characters, the cent symbol, pound symbol, currency sign, and yen sign. This is only 4, yet we're adding quite a bit more than that by including the entire 165 region. You can see that we jump from about, or what it was originally, 126 up to 165.
Mm-hmm.
So let me set this back to its default so that we end off at the tilde character, 126, and let me add in an entire block by copying and pasting this region so that we can add on the range of 162 to 165. So range 162 for start and 165 for end, and then run to make sure that the characters that we're using still work. So we haven't broken anything, yet we've optimized the texture that we're using by not including characters that we didn't need.
Very nice.
And I think that really covers everything that one would need to know about the character region, showing multiple regions and how to access characters that are farther down in the Unicode section.
I agree. All right, let's go ahead and jump back over here. So that really takes care of everything. We've seen that we need to go in, and to get this whole thing rolling, let me go ahead and just pull up a pointer. First thing is we added in a sprite font asset into our project, which was really just an XML file that allowed us to specify what TrueType font we were going to be referencing, the size that we wanted to create our font at, and I keep calling it a font, but of course it's a sprite font. But what size we wanted the font to be at, the spacing, the style, and then from there at build time, the content pipeline took all of this information in the XML file and generated our font, or our sprite font, if you want to call it that, which is the XNB file. And then inside our code, we simply created a sprite font object and used the content manager to load the font into the sprite font object. Then, through a sprite batch, we were able to call upon drawString using one of 3 different method overloads to draw out the text that we specified utilizing the sprite font object to specify what font we wanted to use. It's really that simple. From there, Logan took a little bit of time to explain all of the different properties that we could adjust in the XML file, and we ended the whole thing off with taking a close look at character regions and how we can keep our font file or our sprite font optimized, so there's no reason to have a very large file that contains a bunch of characters that you're not going to be using. We also looked at rotation, origin, uniform and non-uniform scale, and we took a look at the difference between size, scaling, and also sprite effects. So that really covers everything that we needed to talk about in order to provide an introduction to text drawing. And with that, that is going to wrap up this video. Thanks a lot.